Welcome to Thank You for Your Reply, where we dive deep into the strategies and insights of real estate's most innovative professionals. I'm your host, Rich Peterson, founder of the Reply AI. At the Reply AI, I take a consultative approach to helping businesses integrate automations and AI tools so they can get back to working on their business, not in it. In each episode of the podcast, we explore the real practices driving success in today's market. No fluff, no pitches, just real conversations with real experts sharing real results. Today's episode is another PropTech Pioneers spinoff, a special segment of Thank You for Your Reply that brings you conversations with the minds behind real estate's technological transformation. While our main series explores the daily experiences of real estate professionals, these focused episodes introduce you to founders and innovators who are creating practical solutions for the industry's biggest challenges. Before we dive in, please make sure you subscribe to the podcast. Your engagement helps keep the show running. Without further ado, here we go. Hello, everyone. Thanks for tuning in to another episode of the Thank You for Your Reply podcast spin-off of PropTech Pioneers. Today, we're talking to Vit Vimal, the CEO of TULI. Thanks for taking the time today.
Thanks, Rich, for having me on the podcast today.
So just to start off, if you could give people an idea of what your company is and how you kind of end up founding it.
Yeah, absolutely. I'll start off with the kind of background about myself, and I'll go into more about the company. So I started off kind of in architecture school, worked a couple of years in the space, and then really didn't want to focus more on the aesthetics of buildings, but really the technicalities of what goes into these buildings, how are they built, how can they be more efficient, and did my master's of building science. From there, I graduated and worked at a real estate development company for about 2.5 to 3 years, where I got to work with developers all across North America, helping them be more sustainable, helping them build out their buildings a bit better. And through this experience, I learned there was so many inefficiencies in the real estate development market. There was inefficiencies with how buildings were developed, how communication was happening, and most kind of in my line of work was how sustainability was addressed. A lot of the work we were doing was so kind of tedious. You put it into Excel sheets, throw it into databases, and you do the same thing over and over. And I found there to be a big gap with what people wanted to do versus what they were actually doing on site. And I want to do something about this kind of entire environment. So that led me to quit my job and build out a company called TULI, where our goal originally started off kind of purely on the sustainability side. How can we make buildings more sustainable? How can we choose and procure materials a bit better? And then eventually we started to add in some more functionalities with helping out the architecture industry, design out their buildings a bit faster, doing some building code reviews, and kind of adding a whole bunch of features and lines of work to make buildings be designed better and faster.
Yeah, looking at your website, it's like beyond me, my capacity of understanding sort of because I don't have an architecture background and don't know how to really read schematics and all that stuff. But the design and flow of the website makes it, to me, seem a very intriguing system platform that you're building.
Thank you. Yeah, it's not as complicated as you would think. Once you start to learn kind of more like the how to read these blueprints and just kind of have some optics, we try to make it as simple as possible. But I realize that it's still a little kind of crazy and out there, but with more time and more kind of energy, we'll make it a bit more streamlined.
Yeah, and because one of the remits or the kind of the things you're trying to solve is some sustainability, right? And energy savings with it.
Yeah, I can speak a bit more about the sustainability element of it. So right now, for a buildings actually account for some of the most carbon emissions in the world right now. I think the stat is currently at 40% of the global carbon emissions come from buildings itself. And new buildings are being built right now. About half of its emissions over 60 years come from energy, and the other half of its emissions come from the building materials itself. So it's something, the building materials side of things is something that no one really thinks too much about. Why does like the concrete that we use, why does the drywall, insulation, why do these elements contribute so much to the carbon emissions? It's the entire kind of emissions process is called embodied carbon, which is where our company first started off in. So embodied carbon was kind of what is the carbon emissions of your building materials from the time it takes to manufacture, produce, refine these materials to the energy it takes to bring them to site and kind of install them into your building. And things such as concrete was so carbon intensive. And if we want to meet our climate goals and in order to kind of reduce the overall greenhouse gas emissions in the atmosphere, we need to procure better materials. And by better materials, I mean materials that are better for the environment once they're kind of thrown into landfills, materials that are better and faster to kind of build and procure onto the site, or building materials that just kind of sequester carbon and kind of suck up the carbon emissions from the atmosphere. So there's this huge kind of need for better, more sustainable materials and that actually being implemented into your buildings, which is a huge challenge right now.
Yeah, yeah. And it's a race that we need to win.
Yeah, absolutely.
Have you heard of the this is sort of a related bit of a tangent that I saw it a couple of years ago, but then I saw a social media post about it again. This paint, someone invented a type of paint that reflects 99% of the solar rays or something like that. It's like a white paint that so the thought being paint rooftops with it. I think it was for
Yeah. It's actually really the rooftop situation is kind of a really interesting space, and solar kind of um reflectance or emittance or kind of absorption is such a interesting space to kind of be around. The paint situation is like once the sun rays kind of hit the roof of your building, it reflects off, so your building doesn't actually um, kind of suck in that energy, and you need to start to cool it a bit more because of how much heat it's absorbing. But the cool thing with the sun is like in winter dominated climates, like in Toronto, we rely so heavily on the sun to heat up our spaces
oh
during
yeah
winter times. So a really cool strategy, kind of going on this like tangent line, is trees. Like if you put a tree right in front of your kind of your window, for example, it would be able to block out the light or the sun's rays in the summer because it's full bloom. It's a bushy, big tree. But in winter, all the leaves fall off. So now it starts to let in sunlight into your building and it allows you to kind of have this passive heating. So there's a lot of these like really cool strategies that you can put into your buildings that are very intentional to actually like use the heat from the sun or not. And that includes things like paints as well. So yeah, there's a lot of innovation happening in this industry in that sense.
yeah. Yeah, it was one of the things I joined when I was in eighth grade. I joined the Earth Club, and and yeah, and learned all about recycling and all the kind of save the planet kind of stuff, and have been that minded of that in that way for since then. But so yeah, I mean, this is a battle many people have been fighting for so long.
Yeah, and we still need to fight more and more
Yeah,
every single day. So it's a really interesting space to be following.
yeah, and Tuuli brings up things I hadn't even thought of in terms of buildings. So, I know about like, heard you hear stuff with the what are the volatile the VOCs and stuff for like just health wise, but and obviously the obvious things for sustainability with buildings, but it kind of brings up a lot of points that I didn't even think about. So I'm sure other people will be equally impressed by it.
Thank you.
So speaking of Tuuli, so can you walk us through how the Tuuli AI agents that you build have help architecture firms automate their design process and what kind of efficiency gains your early adopters are seeing?
Yeah, for sure. And I'll kind of paint two pictures on the two different spaces that we're on. I'll first focus on the sustainability side, on this embodied carbon building materials. So traditionally, if you want to do a embodied carbon study for your building and want to reduce the carbon emissions from your materials, you would first go to your architecture team, start to develop out a list of all the materials used in your project. And this sounds pretty simple. You would think like, hey, like you should know what materials and how much you need of it on your building. But that's actually one of the most challenging parts is finding out how much materials to a high level of accuracy that you're actually using on your project, which manufacturers you're using, so on and so forth. So you need to take that architecture kind of materials, put it through, send it off to a consultant like myself when I was at my old company. And I would take about 8 weeks of kind of back and forth communication between a whole bunch of design teams, put it through kind of a software of some sort or a glorified Excel sheet, attach materials, and then say, "Hey, Rich, for the building you sent me, you're seeing about 600 kilograms of carbon emissions per meter squared." And you would be like, "Cool. Like, what do I know? What do I do with this number? Is that good? Is it bad? How should I reduce it? How should I do something about it?" And we would kind of go on a consulting practice to do that. But with Tuuli now, we've actually automated that entire workflow where with our architecture stream, you can go into these design files, start to complete material takeoffs, clean out your building files, and essentially create a faster, better material kind of list and eventually send it off to our sustainability platform itself, where we can simulate out your carbon emissions of your buildings with a couple of clicks, give you some recommendations of, hey, here's some like alternative materials you can use. Here's some strategies that you can take. Here's who you can talk to within your team to reduce out the carbon emissions. And then eventually you can even compare yourself, your building to other buildings to see, hey, is my competitors doing better than me? Am I doing better? Like, where do I stand in this kind of embodied carbon hierarchy? So that's just like one of the many things that our company can do. But on the architecture side now, we've actually built out a co-pilot for these design softwares. So we're primarily in a program called Autodesk Revit, where you can design out your buildings. And what we do is essentially through natural language, you can automate your building design. So what would traditionally take several hours to do something as simple as putting dimensions on a floor plan, we can say, "Hey, Tuuli, can you dimension out my floor plan for grid lines or windows or whatever the case is?" And through a couple of minutes and a couple of Python scripts, you'll be able to execute that command.
Cool. And you were talking about the comparing to your competitors. It made me think of, what if you had some sort of, like, how realtors have, or MLS, there's comps for the other properties. You could do like a carbon comp. Be interesting.
Yeah, it's actually a pretty interesting thing that you kind of brought up, which is carbon is everyone's problem. It's not like me versus my other competitor, but it's also is. There's a lot of ESG investors. There's a lot of policies kind of funding projects that are more sustainable. So there is that competitive element of it, but really understanding, hey, like if your building is 600 kilograms per meter squared, is that a good thing or is that a bad thing? You need to kind of benchmark your building against others. There definitely needs to be more work in the space, but it's always helpful to kind of understand what that number actually means for you.
So is that a good thing or a bad thing? Like, is that higher than average, or?
Yeah, it really depends on the building type itself and kind of where that building is. But 600 is in Canada at least, it's pretty high. You could get to 300, 400 pretty easily, push for like 200 if your building is mass timber and kind of has all the bells and whistles. So 600 is traditionally more on the higher side.
So when we talked prior to this podcast recording, you were talking about the Lady Cilento Hospital case study, which I thought was really interesting. If you could dive into that, and also kind of talk about how TULI helps architects incorporate evidence-based design principles for human health and sustainability.
Yeah, absolutely. Lady Cilento Hospital is one of my favorite projects. It really got me to move away from purely architecture for the design aesthetic of things to thinking more about why are we even building these buildings in the first place? Who are we serving? Are we adding any value to humans' lives other than this kind of visual aesthetic of things? So, for everyone listening on the podcast, the Lady Cilento Hospital is a very good case study out of Australia. And what this hospital did that was very unique was it added a whole bunch of elements to the building to make it more, to increase wellness and health of the occupants. So they added more access to natural light. They added very tight envelope systems to let kind of to make the building the air feel more fresh, less kind of thermal kind of uncomfortableness. They added a lot of trees and vegetation, a lot of corridors and kind of access to balconies so that every kind of patient had access to this incredible connection to the planet itself. And what they started to see with their kind of patients was the time it takes to recover was faster than it traditionally was for any other hospital. So you start to understand that the intentionality of the architects and the designers for this building to connect to the planet and kind of incorporate more of these like sustainability, health related elements of a building so that the patients and the people kind of occupying these spaces live happier, healthier lives. A fun case study of where this kind of originated from was in the 90s. If you had smallpox, what the kind of traditional treatment was is you take a lawn chair, you put it in front of your window, and you just soak up the sun for several hours. And over time, we started to lose kind of sync of such a old practice, and the Lady Cilento Hospital kind of brought that back. So that's really what kind of like pushed me to really think about what are we doing with these buildings? Are we building it for the kind of aesthetic, or are we building it for the people living within it, the people using it, the environment around it? And that got me to kind of push myself more into the sustainability side of things. How TULI kind of helps in this process is not as much as I kind of wanted to be completely honest, but we're kind of slowly progressing to kind of go into it. And you brought up a pretty good space of VOCs. But what we do is we help a lot on sustainable material procurement. So how can you implement materials that reduce carbon, but how can you bring in more natural materials as well? One of the best strategies in our industry for embodied carbon is more on mass timber. So creating buildings that are made out of wood. So whenever you walk into a building, you just see these facades of wood and you start to feel kind of more connected to the building itself. Other strategies we could help out with in the future is ULEF, VOCs, kind of looking at materials that are not toxicating for the environments that they're in and procuring materials that are more healthier for the occupants, selecting mechanical systems that filter the air a bit better, and kind of baking in these solutions into a building's design decisions.
On the topic of materials, I'm thinking of another video I saw a couple of days ago. It was showing how in Japan they would do the traditional method of they char the wood planks to put on the outside and inside the homes because it has various sort of benefits to the building and to for pests and things like that. Do you have any thoughts on that?
Yeah, funny enough, I probably watched the same video as you, and I thought it was beautiful. There's a lot of aesthetics kind of involved in it. And I think one of the biggest goals with charring it, and don't quote me on this, but I think it was to seal the wood itself so that it protects it against kind of moisture or you don't see it rotting faster. And so there's these kind of additional benefits in that. But using like wooden materials is something that when you kind of discard it in 60 years, you see a whole bunch of sustainable benefits from kind of it not like lingering in landfills for several years or doesn't kind of pollute the environment, assuming it's kind of recycled properly. So those are my kind of thoughts on that. But recently, I actually had a chance to go down to Japan and see some of the construction materials that they're using, and a lot of their buildings right now are still built with wooden materials. I'm not surprised that they're using these kind of unique practices that we don't typically see here in North America.
Yeah, that's the thing that cracked me up where it was like the charring helps deter termites, and I was like, well, yeah, that makes sense. Like the termite coming along would be like, if that's burned, I'm not eating that.
Yeah, actually, termites are a big thing in Japan. I went to this old, like, historical building from 1950s, and we were just kind of going around the building, and just taking in the materials as we kind of do, and we just see like these like big concrete like columns, and all you see is just like termite holes everywhere on this wooden piece, and you're just like, are they reinforcing this somehow? What's happening? Are they going to like what are they going to do about this? termites is probably one of the biggest issues that they're solving with this charred wood.
It looks like a fun process to do as well.
Yeah, and it's beautiful.
Yeah. Okay, and then so back to AI and architecture. What technical challenges did you face in translating those complex design processes into automated workflows? And did you have any surprises that came along when you were doing that?
Yeah, so one of the biggest issues with kind of bringing AI to architecture is there isn't a lot of ways right now to take a building blueprint and understand actually what's happening in it. So imagine I took a floor plan of your building right now and I sent this to an AI, it would have no idea of what is a wall, what is a winding, what is a stair, like where do I calculate area from? Is it the outside of the wall or is it inside of the wall? Or there's a lot of challenges to understand visually what is happening on a project. So one of the biggest challenges that we're facing right now is this technical challenge of how do we translate a blueprint into more of this kind of a readable language that we can start to implement AI on top of. So that's something our kind of CTO and team is taking a look at right now is how can we build this next layer of AI or vision AI to start to read these complex building floor plans. So that's something I kind of noticed. And I think a lot of the industry actually realizes that this is one of the biggest challenges. And was pretty surprised to hear that um, this comprehension of blueprints and comprehension of their plans was something that was so difficult for them. A lot of QA QC that they couldn't kind of do before would be enabled with TULI itself. So there's a lot of this trickle on effect with what we're building right now.
Does it makes me think of one with was it OCR scanning, where you make a photocopy or you scan a document and it's able to read all the text reliably. I remember when the first time I actually scanned something and it actually faithfully captured the text. I was like, "Whoa!" uh, but I'm sure there must be some similar process that goes on there with translating a drawing.
Yeah, I think it's something that time will kind of fix that issue. It's just we just need a bunch of data to train the AI, being like, hey, an architect might kind of draw a window with two lines with nothing in the middle versus someone might have a different way of doing it. But these both ways are us as humans when we look at this floor plan, we can identify what a window is, and that's just the same data points that the AI needs to do the same exact thing. So with time, it'll get it. Right now, it's still a pretty big challenge, but one of the bets that we're making for the company is vision architecture will be much better than it currently is. We can start to kind of use that into our technology itself.
Yeah, it's true that AI, when the learning the way that a computer or an AI has to learn has to learn not only what, in this case, what is a window, but it also has to learn in correlation to that what is not a window. Like it's like a very long-winded process.
Yeah, absolutely. There's like what is a wall? What is a an exterior wall versus an interior wall? What's a window that's a kind of not a maybe your kitchen door is a window kind of door. Like how does it differentiate that? And I think that accuracy is so important. We can't have a solution that's 90% of the way there. It needs to be 100% accurate because it starts to have a lot of trickle down effects of, oh, if I labeled my window wrong, that starts to skew my energy simulations or starts to skew the amount of window I procure for a project. So there needs to be a lot of accuracy to kind of execute the vision that we have at least right now.
It's not just like is my document wrong, but like if someone has to, if you can't trust what the AI did on the blueprint, and someone has to go in there and check every single metric on it, because yeah, that makes sense.
Yeah, I think to that point, one of the things we were looking at is building code reviews right now with our software, and we might be able to pick up 50% of the building code errors on your current project, but we can't tell you which 50% is still exists. So now it's up to a human to go back and now do the entire review all over again just to figure out what needs to change.
What it caught?
Yeah. So getting 90% of the way there, 95, 99%, it's just not good enough. It has to be 100% accurate. But then again, there also always needs to be that human layer of things because we just can't trust AI to that 100% accuracy.
Yeah, when you put the shovel on the ground and then start building a building, and it's like, wait, who designed this?
Just a couple of robots in
Yeah,
SF.
yeah. I mean, you might get it there at some point, especially when the overlords take over. So we also, in the prior conversation, we talked a little bit about agentic, so like the agentic workflows and micro automation systems. How do you see those technologies transforming the broader real estate industry beyond just architecture in the next few years?
Yeah, I think agentic workflows are going to be the biggest change we'll probably see in our day-to-day lives. Everything from, say, you're scheduling a vacation and you want to go to like Bali for a week, you just tell it, hey, I want to go from Bali from this date to this date. I'm pretty flexible. Here's my budget. And the agents will be like, hey, I'll book you the flight. And then I'll tell you exactly the dates. And then the next agent will tell you, here's a couple of hotel options in your budget range. Then I'll book it for that. And then I'll find you like some restaurants and make some reservations for you. So agents will be there every step of the way for humans. And I think that's going to be the same case for the real estate industry itself. Beyond architecture, where if a real estate developer is about to submit a permit, maybe there's like an agent that goes to the city and collects the required documentation you need and sends it back to the developer, goes through the files itself, finds out, hey, here's where all the information exists, and sends it to the city with the approval of the development managers. So there's a lot of like basic tasks that are so small right now, which might seem too small to kind of build a whole kind of piece of software. Out with agents in the picture, these like kind of micro kind of systems can be automated with the use of agents. Uh, I think the whole industry is gonna there's gonna be a lot of agents being implemented into it. But for the real estate industry, I think it's traditionally a very old industry. A lot of the practices that you see within the industry are a bit slower to kind of innovate on. Even with AI right now, you see AI in healthcare, you see kind of this modernization of the tech work stack for lawyers, you see it for insurance companies, but who's actually doing that for the architecture or AEC industry? And the truth is no one really, because it's just it's such a slower industry to kind of make decisions and kind of move the needle on things like agents and AI. So overall to say agents will take over eventually, but it'll probably be one of the last industries to kind of let that happen.
Okay. Just because it's stubbornness, inherent
Stubbornness, lack of trust, um, everything kind of in between. Yeah.
With your background in sustainability and building science, how does TULI help bridge the gap between aesthetic design and practical sustainability requirements?
Yeah. So with my background in sustainability, building science and architecture, I have this like pretty unique blend of kind of aesthetic practices to more of the technicalities to the sustainability. And traditionally, these three things shouldn't go together. Like no one is looking at making a building extra aesthetically pleasing, but also making it more sustainable because these two things they clash with each other. For example, if I wanted to throw in like a concrete facade of some sort that is like very beautiful and very like aesthetically pleasing, it doesn't help with the sustainability of the building. And traditionally, a lot of the aesthetic kind of strategies right now are very carbon intensive. So I think that what I bring kind of to the table with this is trying to help architects design out their buildings a bit faster, a bit better, and focusing more on the sustainability side of things. And that's kind of the vision and goal with what we're building at Tuuli. We want to give teams more power to make better decisions with their building itself. So it's from things such as like material procurement to using less energy for your buildings to designing out your buildings a bit faster, helping out with better communication. Maybe through these kind of like things, we start to cut down costs a lot for these architecture teams and development teams that they're able to make more affordable units in their buildings. There's a lot of these like trickle on effects But over the next couple of months and years, we're going to be more intentional with how our team kind of bridges the gap between our vision of making buildings more sustainable, more affordable, and kind of bridging what's happening in the industry right now.
Would you say that I was talking about when you were talking about like the sustainability initiatives clash with architectural or like design? So you have form over function and function over form. In my mind, function over form would probably tend to be more sustainable because you're not putting some extra thing just because it's pretty.
Yeah, that's exactly it. And that's like what you said around form over function and function over form has been one of the biggest debates in the architecture industry since maybe the 870s, where every single architect starts to kind of like has this dilemma of, are they an architect that prioritizes form over function or function over form? And to what level do you prioritize it? It's not like either or, but you kind of sit as
It's
a
like a
slider.
slider bar.
Exactly. Are you more on the form side or are you more on the function side? And traditionally, if you want to be more of a sustainability oriented kind of developer or architect, you're sitting more on the function side. What is the purpose of this building? Is it to serve the people, the environment, or is it to be more aesthetically pleasing where people can connect with it in kind of a more deeper manner? I think I lost your audio here.
In Paris, there's the Louis Vuitton store. It's designed to some sort of facade on the outside is designed to look like a big silver Louis Vuitton bag or a suitcase. It's pretty wild. That's when I just thought of like, oh, what's one that would be a slider all the way to form.
Yeah, and that's a great example. The form is kind of to serve this ulterior purpose of maybe it's the marketing. Now you like maybe out of all the kind of stores on the street, you notice the Louis Vuitton and kind of that's your kind of your key landmark in that area. So it might be like a marketing side of things that they're kind of going after. But better, kind of bigger example of that is in Toronto, we have the CN Tower. What is the point to the CN Tower? Is it purely on the form of the city kind of serving the aesthetic pleasure or the Sydney Opera House in Australia? So there's a lot of these like form kind of fitting buildings, but there's also some of the function kind of form fitting buildings as well. But they all serve their unique purpose and one isn't as important as the other, but in the climate change kind of war that we're facing, function needs to be prioritized a bit more.
Yeah, yeah. It would be a sad looking landscape if it was everything was function, but
Yeah,
it'd also
exactly.
be sad if the earth perished from our actions.
Yeah.
So, can you share a specific example of how TULI transformed traditional architecture workflow, particularly in terms of sustainability analysis?
Yeah. I'll lean more on this embodied carbon side, and I'll communicate a bit more on the architecture side of what we're building. So with the Copilot, a lot of what you can do is through natural language, you can automate these tasks within your platform itself. So things that would take in 20, 30 hours, you could automate it a bit faster with Tuli. So in the material takeoff piece of it, where I was kind of mentioning how an architect needs to kind of go and like communicate and take a bunch of time to figure out what exactly the materials are for your building. With Tuli, we could automate this process. So we could help you clean out extraneous like materials into your building, such as is there something that you designed out but you're not actually using your file? Let's like take that out of your building and start to like clean up your file a bit better. Let's use some labeling functionality to label your materials a bit better so that we know this 25 MPa concrete, is that something that you're using for your floors or is that something that you're using for a playground right next to your building? Like how do you label these materials a bit better so that we can actually know where it's coming from? From there, we can start to classify what materials can we actually use to calculate the carbon of your buildings and what can you not. So in this case of this playground concrete, it's not really a part of your building, so it's not considered a part of your embodied carbon number unless you're considering the entire site. So let's take that playground, kind of everything, all the emissions associated with it, and we'll isolate it to the side. So using kind of these cleaning, labeling functionalities, we have this clean data set of materials that we can start to use our kind of next line of software to simulate out your embodied carbon. So once you can go into Copilot and be like, can you create a material takeoff that's clean and I can use to run an embodied carbon simulation? Takes that information, creates a material takeoff with the appropriate categories, and creates an Excel sheet. So from there, we can take that Excel sheet, put it into our embodied carbon software, which will start to attach materials to it. What manufacturers are you using? What materials are you using? What's the carbon emissions associated with it? And we'll finally come out with this number. So let's use the 600 kilograms of CO2 number once again. So we have this number and we realize this building can probably be 400, 300, or if you're chasing after a policy, let's see how we can kind of help you to meet this policy. We can go into our material recommendations and see, hey, let's change this concrete from this pretty carbon intensive manufacturer to someone that uses more recycled material into their concrete. Let's use that and see how that kind of affects your carbon emissions. Let's use a different type of insulation into your building. Let's use these different material suggestions to figure out how you can reduce carbon emissions. One of the cool things that we do behind the scenes at TULI is what we call a multi-objective optimization, which is understanding we do, say, 1,000 simulations of your building with different materials, different strategies. And we start to point this out on a graph of on the y-axis, it might be something like energy, and on the x-axis, it might be carbon from your materials. And we start to kind of point these out and find out what is the best strategy that reduces the overall carbon emissions from materials and helps you reduce out the energy. So we do this practice and we help these teams get to the best kind of carbon emissions of the buildings and help them understand how your building is currently performing. And maybe you don't set these strategies for your current building, but maybe for your next project, you start to kind of think in the back of your head, like, maybe I shouldn't start off with using this carbon intensive manufacturer. Let's just start off with a more sustainable manufacturer, or let's just eliminate carbon or our concrete overall and use mass timber. So that's kind of one workflow where from end to end, how we can help with our.
So as AI continues to evolve in the AEC industry, how do you see the role of architects changing, and how is TULI positioning itself to support that evolution?
Yeah. So I'll probably be using AEC a lot in this kind of explanation, but just to let the listeners kind of understand what AEC is architecture, engineering, and construction. And there's an extended version of this, which is ACOM, which is architecture, engineering, construction, operations, and maintenance. So it's just essentially all the practices that come together to build out buildings and manufacturing. All the construction you see can be grouped into this like AEC, ACOM, whatever you want to call it. But to answer your question around how does AI continue to evolve and how is TULI kind of positioning itself to support this evolution? So our goal right now is to enable architects. We've branded our first tool as a copilot. So similar to like the original definition of a copilot. So in the flight, see the role of the copilot is to support with the communication, to help the pilot essentially do their job of making the plane fly. So what does the copilot need to do to support that role? That's exactly the same thing that we're doing with TULI. Our goal is to support the architect to do what they do best in kind of their day-to-day practice. Let's take more of these like tedious kind of mundane tasks and let the architect do what they do best. So in architecture school, what we were taught to do is be more creative. Let's use some more kind of problem solving skills. Let's start to develop out these problem solving skills. Let's use some more aesthetic materials. Let's be more creative with our building. But when you actually go into practice, you get hit with a huge wall of unnecessary work that we're not trying to do, which is things like dimensioning of floor plan. So adding like these like lines to your building to tell you from this wall to this wall is about 10 meters long. This process of dimensioning an entire building can take anywhere from 10 to 50 hours. This is a lot of time spent by an architect doing something that could be essentially automated. So let Tuuli take on some of these more unskillful work and let the architects and kind of teams do what they do best, which is being creative and problem solving. So that's our kind of our role to support teams in this kind of evolution of AI. But in the future, as we kind of go through the process, there might be more that we see beyond the Copilot. So something like doing better QA, QC on your buildings and making sure that there isn't this like functionality of your buildings. We've probably seen in like a whole bunch of like these social media posts of, hey, look at the architect open the door right onto my toilet. So I need like squeeze through this like narrow corridor to like go into my toilet. Like, how do we reduce these like errors in the building? So that's kind of where we see ourselves fitting in the future, helping support teams to do what they do best and let us take on some of the more tedious and mundane tasks.
Oh, so Tuuli, because we're talking about like architecture in other parts of the world and all that stuff. And does Tuuli work anywhere? Is it a good? Oh yeah, what I was thinking was that the materials for construction and all that stuff, it's going to differ if you're in a different country or something like that. So this different data set, is that something that Tuuli can roll with, or is that something that's coming?
Yeah, it's a great question. So for our architecture copilot, which sits within programs like within Revit right now, it can be used globally anywhere. We have some teams kind of we sent some teams some keys in Singapore. We have some teams in like UK. We have some teams in America. So that it can be used anywhere because all you need to do is through natural language tell the program what you want to do and let it kind of do its work. But more so on the material procurement, material kind of sustainability side of things. Right now, we're primarily in North America. We might have some kind of potential in Europe, but that's because the data sets that we're using, the materials that we know, there's these things in the industry called EPDs, environmental product declarations. Essentially, it's a nutrition label for your materials. So your concrete has an EPD and it tells you what the carbon emissions associated with it are. That practice is still very lackluster in North America, but more lackluster spread throughout the world. So like those data sets are not collected globally and we can only kind of implement it in so many different regions. So right now where we fit best on the sustainability side is within North America.
Last question, what's your goal for Tuuli by the end of 2025?
Our goal for TULI by end of 2025. It's a good question. We're pretty ambitious with kind of what we're building out, and we're going so fast with our development. Also, sky's the limit, but our biggest goal for 2025 is to help a architecture team from end to end being able to automate something like building codes. So let's scan your building code, your floor plans or your elevations. Let's look at the building code and let's use these two files to tell you where you're making a mistake and where you're not making a mistake with high degree of accuracy. Alternatively, one piece that we kind of want to look at as well is maybe the RFP process. Like how can we help submit more proposals? How can we help kind of the design of this building in a faster, quicker manner so that you can submit it for a competition or the design of a building somewhere. So we have a lot of ambitions for the end of like 2025. And I think these are some of the biggest ones that we're facing or we're looking to address.
All right. Well, thanks so much, Vit. I think it's a really good conversation for everyone to be having is the sustainability piece in particular, the trajectory of our environment right now. So we just, we need more people like you out there solving problems like that.
Thank you so much, and thank you for having me on the podcast. It's awesome to kind of take a step back and reflect on podcasts like this, where I can really like this is kind of how it evolved. You just when in your day to day, you know it, but you just don't take the chance to like take a step back and like look at it. So it's really kind of fun to just kind of go down memory lane and see this is kind of how we started and kind of how we evolved over the last couple of months. So yeah, thank you for kind of having me on the podcast today.
Yeah, my pleasure. Thanks for sharing.
Thank you.
That wraps up another episode of Thank You for Your Reply. To our listeners, you can find show notes and links below this video, or if you're on audio, it'll be in the show description. If you enjoyed the episode, please like and subscribe so you'll be able to catch the new episodes when they drop. If you'd like to talk to me about how you can optimize your business with tried and true AI technology, please head on over to thereply.ai to get in touch. Until next time, keep innovating, keep growing, and remember, you don't rise to the level of your goals, you fall to the level of your systems.